All right, question 7, last question for the test review. The function h defined by h of t equals the quantity 4.9t plus 30 times the quantity negative t plus 12 models the height in meters of an object t seconds after it's dropped from a mountain in Utah. Find or approximate the time when the object hits the ground. Explain or show your reasoning. So if we're thinking about this parabola in our minds, we should be thinking about that they're somehow up here on top of a mountain and they're just dropping the stone down or the object down, and they want to know when it's going to hit the ground. So in our minds, we should be thinking, okay, well then that's the x-intercept that we're looking for. We're looking for when the stone or the object is back on the ground. So we're looking for the x-intercepts. Because this is in factored form, that's easy to find. We need to set both of these equal to 0 and figure out when it would hit the ground. So I'm going to put 4.9t plus 30 equals 0, and I'm going to solve that like I'm back in algebra 1, and then this negative t plus 12 equals 0 and solve that like I'm back in algebra 1. So this one I need the 4.9t to be by itself, so I'm going to subtract 30, and you cannot just take subtract 30 and say it's the x-intercept is negative 30. We can't just do the opposite for this one because we have a coefficient here. So then the next step, I would divide by 4.9. So negative 30 divided by 4.9. So my t would be negative, let me get my calculator, 30 divided by 4.9. That would be a negative 6.1 for that, which means that that's talking about something all the way over here that's before they drop the stone. So we don't care about the negative side because one, we can't go back in time. So, and the graph doesn't follow the exact route of the stone in the part where it's the negative side. So that x-intercept doesn't make sense. So we're going to ignore that one and we're going to talk about the other one and see if the other one makes sense. So that I'm going to solve this one, I need to subtract 12 from both sides here. Now, when I do that, that cancels out. Make sure I notice that this is a negative t equals 0 minus 12 is negative 12. If I didn't take the negative t, that would mean t equals negative 12 and negative 12 wouldn't make sense either. But because I have that negative t, there's technically like a negative 1 here. So I would need to divide both sides by a negative 1. And then t would equal negative 12 divided by negative 1 would be 12. So this one does make sense because it's a positive 12. So that must be where it hit at a positive 12. So the time that it hit the ground is at 12 seconds. All right, and we found that by finding the x-intercepts, and one of them makes sense and one of them doesn't. All right, and then for part B, it says from what height is the object dropped? So that means that we're talking about this part right here, and that part right here is the y-intercept. And when we're looking at the y-intercept, we can't find it directly from a factored form. We need it in standard form. So that means that we would have to multiply these two inside the box. The nice thing is that the only part I care about in the box when I'm looking for a y-intercept is this box right here, which means that it would be the 30 and the 12. So when I multiply 30 times 12, I get 360. So that must be the height that it dropped at. So they dropped it at 360 feet from the mountain. All right, so that was just finding the x-intercept and the y-intercept, basically.